The following tutorial is meant to help you understand how to predict the products of a double replacement reaction. We're going to start by looking at an assignment that you guys have and to look at questions 1, 2, and 3 from that assignment. The first thing we're going to take a look at is the sodium bromide plus barium chloride equation. Before we even make a prediction about our products, let's write down what the reactants actually would be. So sodium bromide would be NaBr, and that is actually aqueous. Double replacement reactions are happening in aqueous solutions. Plus BaCl2. That is also aqueous. The next part is we need to make a prediction about what is going to be formed. In a double replacement reactions, generally we say that the metals are switching places. So sodium is going to become partners with chloride, and barium will become partners with bromide. When we write the new formulas, we have to be careful and make sure that we are balancing out the charges based on the ions that are most likely to form. So sodium we know has a +1 charge, and when it comes into contact with chlorine, chlorine has a -1 charge. Sodium chloride would be NaCl. Plus, we also have barium, and barium has a +2 charge, and that's going to match with bromine. Bromine has a -1 charge, so to balance out the charges, we'd have to have BaBr2. At this point in 9th grade, I'm not asking that you guys are able to make predictions about what the solid would be, but in some cases you can kind of just use some common sense. Sodium chloride, table salt. What do you guys know about that? Does it dissolve in water? The answer to that is yes. Yes, it does dissolve in water, so this would actually have an aqueous symbol after it. And the question is, does barium bromide dissolve in water? If you're interested in learning more about that, if you're interested in figuring out if that is a solid or if it would be aqueous, there is a set of solubility rules at the front lab station that you can borrow during class today. At this point in 9th grade, what I'm asking you guys to be able to do is just make a prediction about what you think would be formed if this possibly could happen, and then balance out those equations. So that's the last part, is to balance out this equation. We have 2 bromines on the product side, so we need to have 2 bromines on the reactant side. And we have 2 sodiums now, so we're going to need to have 2 sodiums. Hold on, Liam. And we have 2 chlorines on the product side, and now we have 2 chlorines on the reactant side. Everything looks balanced, so that should be the answer to problem number 1. In the second problem, you're given calcium nitrate plus sodium carbonate. I've gone ahead and written out the equations for both of those. Again, this is a double replacement reaction, and so we need to have the metals switch places. Calcium is going to switch places and become partners with carbonate. Sodium is going to become partners with nitrate. This is a little bit harder because now we have polyatomics involved, so I'm going to walk you through this a little bit more step by step. All right, sliding this over just a little bit. Let's start with the calcium compound. So calcium has a +2 charge, Ca with a +2 charge, and it's partnering up with carbonate. If I looked on a table, a periodic table of elements that had the polyatomics listed on the top, kind of like what you had with your last test, I would see that carbonate has a -2 charge. What happens when our ions have the exact same charge value except opposite plus-minus? They cancel out. So the formula for calcium carbonate is actually CaCO3. We're going to do the same thing for the sodium carbonate. Sorry, for the sodium nitrate. Okay, sodium we know has a +1 charge just from looking at the periodic table and from the work above. And nitrate is NO3 with a -1 charge. So NaNO3 would be the formula for sodium nitrate. All right, the last step would be to balance this out if it's not already balanced. If we take a quick look at the left-hand side, we have 2 nitrates on that side. We only have 1 on the product side, so I'm going to put a 2 in front of sodium nitrate to balance out that compound's nitrates. That gives me 2 sodiums, But if I look on my reactant side, I have 2 sodiums there already. My calciums, I have 1 on both sides, and my carbonates, I have 1 on both sides. So that should be balanced. Here is a quick rule for any time you're trying to figure out if something's soluble or insoluble. Again, you don't necessarily need to know this in 9th grade, but for those of you who kind of get the balancing thing already, it's a good piece of information to kind of move forward with. This is the rule. All alkali metal compounds are soluble. So sodium nitrate is going to be soluble by that rule. Calcium carbonate, however, may or may not be soluble. You're going to want to check the solubility rules if you're curious about that to find out whether or not that is solid or if it also would dissolve in water. Okay, finally for this third equation, ammonium chloride plus sodium sulfate. Ammonium chloride should be NH4Cl. Both ammonia has a +1 charge and chlorine has a -1 charge, so those charges balance out. And then sodium sulfate should be Na2SO4. Sodium has a +1 charge, sulfate has a -2, so that's how we got that formula. Okay, this one's a little bit different from the first two. We're still going to be switching the positives, except in this case, the positive is an entire polyatomic. So we have NH4 with a plus charge, and then here's the other positive, sodium, again, that has a +1 charge. So they're just going to switch their partners. When sodium combines with chlorine, we already have sodium chloride. We know that that's table salt, that will be aqueous. Plus, we have ammonium sulfate, so NH4 2SO4, and that sulfate has a charge of -2. Generally, compounds containing the polyatomic ammonium are soluble, so that should be an aqueous compound. If you check the rules at the front of the lab station, you'd see that that is true. Again, you don't need to necessarily know that, but you should be able to be working towards making these predictions and writing these equations. Last step, as always, is to check to make sure it's balanced. In this case, we can quickly see ammoniums are not balanced. There's 1 on the reactant side and 2 on the product side. So simply putting a 2 in front of the ammonium chloride. And then looking down, that gives us 2 chlorines. So we have to look at the product side. We need to have 2 chlorines. Put a 2 in front of NaCl. Check to make sure that our NAs are balanced. They are. Our sulfates are balanced. And that's it. This is a harder skill. I'm not thinking that in 9th grade that most of you are going to think that this is easy. But with practice, it does make more sense. Again, the basic steps are write out your reactants, and then if it helps you to underline the positives, underline those positives, and then have them switch places. When you are writing your products, just remember that you are balancing out charges just like you did. We started learning this about a month ago, so kind of rely on some of those skills that you have from before.